Okay, today we're going to start Unit 10. Our next unit, this is basically what we're going to start at our fifth 6 weeks. 2 more 6 weeks, and we are done with school. All right, so first thing I want to do is I want you to take a look at this paper here. Look at these numbers. These are monomials. We're going to talk about monomials. So just take a second to look at these 2 columns. On the left-hand side, these are all monomials. On the right-hand side, these are not monomials. So just go ahead and think to yourself and compare to yourself what they are. Look at the differences between them. Okay, so that we don't do too much so that we're not doing too much or waiting too long. The first thing we need to identify is the fact that a monomial, okay, if you look closely, a monomial is a multiplication. It's one term, it's a constant term, or it's the product of a constant term and one or more variables with whole number exponents. Okay? So all of these, this is a product of a whole number and a variable. This is a product of a whole number and a variable with exponents. Okay? This is just a one singular number or a constant. This is a product of a constant and a variable and a product of a constant and a variable. That's what these are. These all have addition or subtraction. It's separated. This monomial is separated from this monomial by addition or subtraction. All these are separated by addition and subtraction. Also notice there's no division here. Monomial means mono, one term. Okay, so this is one term. That's basically how you want to look at it. So the definition of a monomial is one term that consists of either a constant, which is just a naked number, the product of a constant, and one or more variables, or it could be a whole number with exponents. Again, keyword there, whole number with exponents. Now we've already talked about these to some extent. This isn't a brand new concept. This is something that we've discussed before, but a monomial is simply that. It's one term. It's one term. There's no plus, there's no minus. Okay? All right, well, let's look at the next one. Maybe. Take a look at these. These are binomials. What do you see there? Well, now you have 2 terms. Bi, like bicycle, means 2. One monomial plus another monomial. 1 plus another one. 1 and 1. 1 and 1. 1 and 1. Or 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Those are all binomials. There's 2 terms. What is this? Monomial. There's 3 terms here, so it can't be a binomial. We don't call a 3-wheel bike a bicycle. We call it a tricycle, so that's not a binomial. This is 3 terms. This is 3 terms. So those are not binomials. This is 1 term, so that's a monomial. So what is a binomial? And again, you can write this in this, you can write this down in your notes. But a binomial, by definition, is the sum or difference of 2 monomials. So adding or subtracting 2 monomials. And one last little brief introduction. What about trinomials? That's right. It's just three terms. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Again, all separated by plus or minus signs. Okay? Even if I had y's in here, it wouldn't make a difference as long as they're separated by plus or minus signs. In order to have a binomial or a trinomial, you need to have the plus or minus signs in there. Okay? These are not, what is this? Binomial. What is this? Binomial. What is this? Monomial. What is this? Binomial. And this? Monomial. Okay, again, a monomial is the sum and or difference of three monomials. Okay, so you need that preference as we get into it. When you talk about monomials, binomials, monomials, binomials, trinomials, you're really incorporating everything that's underneath what we call polynomials. Polynomials, and these are the notes that you can print out online. Polynomials, okay, are many or one or more, okay, and nomial means term. So when we did a monomial, that was one term. Poly means one or more. So polynomial. So a monomial is a polynomial. Binomial, trinomial, those are all polynomials. So this is the umbrella that incorporates all that. All right. So let's go ahead and try to run through these. Again, a monomial is a number, variable, or a product of number and variables. Okay, if you look at that table there, if you look at that table there, you can see several monomials. Constant, single variable, product of a constant and a variable with an exponent. Okay, here's a constant times a variable times another variable times another variable and an exponent. These are not monomials. That's a binomial because we're adding. That's not a monomial because we're dividing by a variable. We don't want to divide by a variable. This is a binomial. And again, we're dividing by a different variable here. So that's not a monomial either. Okay? A monomial that has a real number with no variable, which a monomial with a real number with no variable. That's called a constant. It's just a number with no variable. That's a constant. It's a naked number. Which of the monomial examples above are constants? So which of these are constants? 10. That's right. Okay. A polynomial a monomial or sum of monomials or terms. Okay, we talked about that earlier. So it can be monomial, but it's also the sum of monomials or terms. Sum or difference, either one. Okay. The sum of two monomials or terms. 2 is bi, so binomial. Sum of three monomials or terms. There's 3, so we call that trinomial. And beyond 3, we don't get much into giving them names other than just being a polynomial. All right. Now, let's talk about the types of polynomials we have here. Okay? What is this? How many terms is that? It's 1, so it's a monomial. 1 term. You got 1 term here. It's a constant. It goes up with this definition up here. It's a naked number. That's still considered a monomial. It's got 1 term. And that term happens to be constant. Now here we have 2 terms being subtracted from one another. So that must be a binomial. How many terms do we have here? There's 1 big term and another term. So that's a binomial. And here, 1, 2, 3 terms. So that must be a trinomial. And then here, 1 big term, 2 terms, 3 terms. So another trinomial. Okay? I want to make one note. Let's look at this one for a second. Sometimes you'll see the word degree. Okay? That'll pop up from time to time. It'll ask you what is the degree of the polynomial or something to that extent. And the reason I'm bringing that up is because it's important to understand that degree is based on the exponent. Okay? The degree of a polynomial is taken or figured out by the highest exponent value. So here, what kind of polynomial is this? Well, this is a trinomial. It's got 3 terms, but the degree is based on the fact that it has a squared term right here. Okay? So that squared term tells me I have a second degree. Okay? So the degree is determined by the highest exponent. Now, it doesn't have a lot of practical applications as far as the degrees and all that other stuff, but it is information that it's good information to have. It'll come up here and there on taking tests and stuff like that. You'll hear it for the next 3 years. You know, what degree is this? Blah 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 blah. Just to understand that the degree is based on the highest the highest exponent. All right, let's move on. Okay, so we're going to simplify these expressions, and we're going to tell whether the simplified expression is a monomial. All right, so the first one we see there is 6x squared times negative 3x to the 5th power. We've been doing this already. This is not anything new. 6 times 3 is negative 18. X squared times x to the 5th is x to the 7th. Is that a monomial? Yes, it is. Okay, and again, this is not an exponent lesson, so I'm not going through all the steps I would normally show you for the exponents. We've already done that. Okay, here we go again. Let's simplify this. I got to get rid of that this exponent out here, so I'm going to multiply. So I'm going to have x to the negative 4th, okay, over y to the negative 6th. Both of these have elevator buttons, so all I'm going to do is switch them. Y is going to come to the top, which is y to the 6th, now positive. X to the 4th is going to go to the bottom as a positive. Okay, so now I have y to the 6th over x to the 4th. Is this a monomial?
Pardon this brief interruption. 7th period boys baseball. Y'all need to meet in the cafeteria today. Thank you. 7th period boys baseball.
That is not a monomial because I'm dividing by a different different variable. Okay. I know we're moving quickly through these, but these are pretty simple. Again, if I work this out, I have negative 4 to the 4th power, which is 256. Because I have an even exponent, I'm going to have a positive answer. And then I have x to the 7th, y to the 7th. Sorry, I said 7th, 12th. I didn't mean to add those. X to the 12th, y to the 12th, excuse me. Is this a is this a monomial? Yes, it is. Okay, it is the product of a constant and 2 variables. All right, here, 9 divided by negative 3 is negative 3. A3 divided by a to the 1st power is a2. b5 divided by b squared is b3. Is this a monomial? Yes, it is. 5-minute warning. Okay. Here, I got a lot going on, so I'm going to simplify the top first. 4 times 6 is 24. A3 times A1 is A to the 4th. B negative 2 times B to the 3 is B negative 6. Over negative 8. A squared B. 24 divided by 8 is negative 8 is negative 3. a4 divided by a squared is a to the second power. Sorry, I made a mistake here. This is negative 2 plus 3, which is 1. See here, I did this wrong. Negative 2 plus 3, I multiplied them. This should be added. Negative 2 plus 3 is b to the first power, which is b. b over b cancels out. So my answer is negative 3a squared. Is it a monomial or a binomial? Or none? It's a monomial, so that's good. All right, that should have been pretty much reviewed except for the identifying whether it's a monomial or not. All right. Now, we've already kind of done some of this next stuff too, so this should be pretty simple as well. Now we are going to combine polynomials. Okay, combining polynomials. Okay, there's a couple steps here. You want to combine like terms within the parentheses first. Then you distribute if necessary to clear the parentheses, because you can't get rid of the parentheses until you distribute it. And then you can combine the remaining like terms. Okay, so here, are there any terms in here I can combine? No. Now, if you have a plus sign in the middle, all you have to do is drop the parentheses and combine like terms. So I have 9y minus 7x plus 15a minus 3y plus 8x minus 8a. Now I combine like terms. So as I'm looking at my like terms, I see, and I'm going to put these in alphabetical order because two things, and I forgot to tell you about with degree. When you do degree, the one thing that's good about degree is the practical application of degree is you line up your exponents by degree. So you got to put your x squared before you put your x to the first power, or x cubed, then x squared, then x to the first power. We've talked about that before. That's kind of how we talked about the close and how we got our naked number. Same thing here. When I line these up, I'm going to line them up by alphabetical order and degree. So the first one I'm going to look at are my a terms. So I'm going to combine like terms. I have 15a squared and negative 8a. That's going to give me 7a. Then I'm going to have x is next, right? So I have negative 7x plus 8x is just positive 1x. And then I'm going to have 9y minus 3y. That's plus 6y. That's all you can do. I cannot combine unlike terms, so I'm done right there. Okay, number 7. Again, notice I have a plus sign, so I'm just going to drop the parentheses and combine like terms. And when I drop the parentheses, the plus sign disappears too. I don't want any double signage. Alphabetical order. The naked number always goes at the back, so I have 4a minus 7a is negative 3a. 5a, I'm sorry, negative 5a plus 5, I'm sorry, negative 5 plus 5, excuse me, cancels out. So my answer is negative 3a. By the way, what is this? It's a trinomial, right? This one, monomial. Okay. Let's go to the next. And notice how you went from two binomials to a singular monomial. That happens. Okay. The next term, again, look here, plus sign. So combine like term, or drop the parentheses. Went over to the other side. It's all right. Now combine like terms. Again, start with your x value first. So there's my highest x value. My highest degreed x value goes first. So my x squared is my highest degreed x value. I have 3x squared plus 4x squared gives me 7x squared. My next degreed x value, which would be this 1x right here, which is xy. So 5xy minus 8xy is negative 3xy. And then my y value, my highest degree y value, negative 2y squared plus y squared gives me negative y squared. I've simplified, but I cannot go any further. What kind of term? Trinomial. Now here, I'm going to move this over a little bit. It's slightly different. Notice the change in my problem. I have a subtraction sign in the middle. With the subtraction sign, we distribute the negative. So now I have 7c minus 5. Negative times negative 8c is positive 8c. Negative times 5 is negative 5. Now, combine like terms, starting with your lowest or your first letter term. So 7c plus 8c is 15c. Negative 5 minus 5 is negative 10. Now, I'm about to have to cut this video off to start my next class. There's going to be a part 2, so make sure you watch part 2. This is the answer for this one. Watch part 2 because there's a little more to this. This is not as simple as it gets. It gets a little more difficult. So I'm going to cut this out, and this is a binomial. Please watch part 2.